Hi, in this video I will go over the multiple choice problems in this section on polar AP practice. I'll do the free response in a different video. Okay, this first one, we are given a polar curve. K is a positive constant, we don't know. And for what value of K, if any, is the instantaneous rate of change of R with respect to theta at theta equals pi equal to 15? So let's just notice here, this is literally the rate of change of R with respect to theta, dr d theta. This is not slope. This is just what do we get when we take the derivative of R. So that would be K times theta to the K minus 1 plus 4 theta. And so what we want is when we plug in theta equals pi to get 15. So dr d theta evaluated at theta equals pi means we have K times pi to the K minus 1 plus 4 pi equals 15. And this we will solve on the calculator. So I will do numerical solve. Bear with me while I type that in. The equation here is K times pi raised to the power of K minus 1 plus 4 pi equals 15. And I'm solving this for K, and I get an answer of 1.451, so that is B. Okay, for this one, we have two circles, we have their polar equations, and we want the area inside 4 sine theta and outside R equals 3. So we want this area here. We need to figure out where they intersect. That intersection would happen when 3 equals 4 sine theta. So 3/4 is equal to sine theta. I'm going to do inverse sine on my calculator because 3/4 is not something that we know. And that is, to several decimal places, this. Now, theoretically, I would need to figure out this one too. And you can do that by symmetries. You can subtract from pi. What I'm going to do instead is, since I know that this midline is at pi over 2, I'm just going to do it from 0.84806 to pi over 2 and double my answer. So polar area, this would be 1/2 times the outer one squared minus 1/2 times the inner one squared. Our entire problem lives between these rays. The outer one is the one with sine, the inner one was just R equals 3. So let me put this in my calculator. You might notice the 2 cancels the 1/2. That could save you a little bit of time. That 0.84806 is an intermediate number. That's why I have it to more than 3 decimal places. Sometimes intermediate rounding causes problems. Okay. Sorry, I typed something wrong into my calculator because I'm not seeing what looks right. sorry, let me do this again. Maybe I made some weird mistake in a previous step. This is the thing about calculator active problems. You can understand what you're doing, but if you make a very minor typing error, it can be extremely hard to figure out where you've made your mistake. Oh, I see what I did. I tried to cancel the 1/2 and I typed something weird in. Okay, and now I get this one. If you're watching the video, that was a little dull. I'm skipping these free response, and then I will do these other 2 multiple choice. These are no calculator. All right, so slope, we know we're going to have the derivative with respect to theta of r sine theta, which would be 4 theta squared sine theta, over the derivative of x, derivative of r cosine theta. So I'm going to need some product rule here. So derivative of the first times the second plus first times the derivative of the second. Similar down here, derivative of the first times the second plus the first times the derivative of the second. And theta is pi over 4. So specifically, we would have 8 theta is 2 pi, times sine is root 2 over 2, and then plus 4 times pi over 4 squared, I'll simplify that later, times root 2 over 2. Here, 2 pi times root 2 over 2 minus 4 times pi over 4 squared, root 2 over 2. What you'll notice is each term has root 2 over 2 in it, so those actually cancel. I can divide each term by root 2 over 2. So now what do I have? I have 2 pi, and then this works out to pi squared over 16 times 4. So that's pi over 4. And here it's with a minus. So this is 9 pi over 4 over... Oh, where did I did something dumb. Give me a second. Oh, it's pi squared. Sorry. So we have 2 pi plus pi squared over 4. I so much wanted those to be like terms that I forgot I had pi squared. So we can multiply every term by 8, or by 4. Trying to make it look more like one of these choices. It's pretty obvious which one it's going to be, but I want to actually get there for sure. And then we can divide everything by pi. So that's 8 plus pi over 8 minus pi, and it's C. Okay. And area of the inner loop here. Inner loops begin and end when r is equal to 0. This means sine of theta is equal to 1/2. This inner loop begins at theta equals pi over 6, and it ends at theta equals 5 pi over 6. So the area of that inner loop would be integral from pi over 6 to 5 pi over 6 of 1/2 times the function squared Now we'll notice we don't see that as an option. We need to rewrite the integrand to get it to match something. So what we might notice is these are both divisible by 2. So I could rewrite what I have there as 2 times 1 minus 2 sine theta. And then we have 1/2 and a 2 that's getting squared. So ultimately that's 1/2 times 4, which is 2. And then this is left being squared. So our answer is B. I know it's hard to read that, but in context you can guess it's the correct thing. All right, that's it for this video. I will do the free response in a separate video.